So this is the fall final. We've got chapter 6, and we're going to talk all the things that are going to be on the final that you need to know for chapter 6. And chapter 6 was when I had to graph exponential graphs. Remember the L-shaped? It was like a curve L-shaped. I also did exponential growth and decay in chapter 6. And we talked a little bit about, like, in the beginning, 1 through 7, these are called rational exponents. So I've got a square root here, but a rational exponent means that I'm going to have a fraction exponent. And what I did is I think I described it as x to the power of mn, something like that. I think it was m and n, m over n. And that means that let me zoom in a little bit. That means that my n comes to the front, the nth root of x to the m. So in a square root, this is called the root. That was the denominator. The number that was the numerator stays with the base. The base in this case is x. So on number 1, where would the 4 go and where would the 3 go? Because I want a 2 with a fraction exponent. So where's the 4? Go ahead. So what's the fraction that's going to go with my 2? 4 over 3. Good job. Okay. Number 2. I don't have an exponent next to the 8. What do I do? It's a 1. It's an implied 1. So is it 6 over 1 or 1 over 6? 1 over 6. All right. And then you would do number 3 for homework. Good. So number 4. If you have the same base, like all of these bases are 3, you can set the exponents equal. So what's going to happen is I'm going to do this x plus 5. When I multiply, I add exponents. Plus 2x minus 1 equals 15. So I'm not going to worry about the 3's anymore. Since all the bases are the same, I can make the exponents into an equation. X plus 5 plus 2x minus 1 equals 15. The 3's are now gone. Doesn't matter what the base is. You make the exponents equal. This is just solving. Like terms go together. X plus 2x. 3x. 5 minus 1. 4 equals 15. So easy. Just solve for x like normal, like a normal linear equation. So I move the 4 with the 15 because they are like terms. 3x equals 11. And then I divide by 3. I'm going to get a fraction answer, and fraction answers are just fine. Totally good. Let's do number 6. I'll have you do 5 for homework and 7 for homework. Let's do number 6. Okay, the bases are all the same. Great. The exponents now. When I multiply, this is an addition problem. Do you remember why it's an addition problem? Let me give you like a super easy one. X to the 5th times x squared. What do I do with the 5 and the 2? Is it 10 or is it 7? 7. You were right, this is 7. There's 5 of them here. 2 more. 7 altogether. So that's why when the bases are the same, I'm adding x over 4 plus x over 2. So I'm just adding that side. The equal sign stays equal. And this is a 4. This type of math problem requires me to get rid of the denominators. I don't want the fractions there. I have to clear the fractions. What do you think about me getting rid of the denominators? What should I do? How do I get rid of the 4 and the 2? No.
Multiply 2 by 4 and 4 by 2.
I don't want to multiply 2. I want to, no one's got it yet. Denominator is important. Yeah. The least common, it's called like least common multiple. What's the common denominator of 2 and 4?
2.
No. What's the number like that they both like? I have to pick the bigger number. You have to pick 4. So I'm going to multiply everything. I think I spelled that wrong. Whatever. By 4. So I'm able to cancel things out. Remember cross canceling? Some of you actually told me that you didn't like cross canceling. Where the 4s, where I can say like, oh, the 4s cancel. All I have left is an x. Do you remember this? And then on this one, 2 divided by 4. Like 2 goes into itself once. 2 goes into 4 twice. This now says x times 2 plus, well, x times 2 is the same as 2x. Equals 4 times 4. Everything gets multiplied by 4. I'm going to have another fraction answer. No problem. 3x equals 16. And then you just divide by 3. So x equals 16 thirds. The same type of thing is going to happen for number 7, where you'll do x over 5 plus x over 3 equals 6. You will for sure have a question on the final like 1, 2, or 3. You will for sure have a question on the final like 4, 5, 6, or 7. The final is 40 questions and it's 200 points. 40 questions. I can write it on. 200 points. Stop, please. Jaden. I'm recording. All right, let's turn the page. We're going to go back to graphing. Let's go to graphing. So these are transformations. I am moving a regular old L-shaped graph, maybe left or right, or up and down. So let me explain to you what counts for what. If I have a number after the x, that's going to move me left or right. If I have a number at the very end, that's going to move me up or down, and that's also called the horizontal asymptote. Sorry, you couldn't see that. So 3 to the x is just a normal graph. But once I start adding things to it, an h maybe or a k, it moves it. Something really important about this h, which happens in all things, absolute values and parabolas, it's the opposite sign. So it's the opposite sign of the h. The k is the same sign, opposite, OPP sign, op sign, opposite sign. So on 8, I have this 3 to the x. Great. 3 to the x is my normal graph. But now there's a plus 2. Up here it tells me that's a left or a right, and it's the opposite sign. So an opposite sign is going to be a 2. I need you quiet in the back, please, gentlemen. Thank you. 2 to the what? Because it's the opposite sign. So 2 to the what direction? Determine the transformation. 2 to the left. Good job. There is no k. It would be like a plus 0. There is no k. My horizontal asymptote is going to be y equals 0. It's going to be a horizontal line on the graph. All right. This one has a k. Let's do the middle. This has a k, which means it has a horizontal asymptote. No shifting left or right, but it has a plus 4 at the end. That's my k up 4. Good job. So that k is also my horizontal asymptote. It's y equals 4. Work ahead if you know these by, if you can do these without help. 3 to the x, 3 raised to the power of x is normal, but there's a minus 6. Down 6. Good job. And my horizontal asymptote is going to be that 6. Y equals negative 6. I want you to do the bottom 3 for homework. HW, HW, HW. So now I'm going to practice graphing. You'll do those for homework. I'm going to jump to number 8 in notes right now. All right. On number 8, it's just a plain 2 to the x. Well, I kind of forget, and I need to make a table of values. So I need to pick numbers that are going to be really easy in an exponent position. I don't want to pick 2 to the 7. That's too huge. I can't graph it. So let's pick small things that are going to make 2 just really easy to work with. So I have recommended in the past like 2 to the, and maybe we could use negative 1 as an exponent. 0, 1, things like that. Easy numbers. Do you remember what happens when I have a 2 to the negative first power, a negative exponent? It flips. So the 2 to the first drops down to the bottom. It's just 1/2. So my ordered pair is negative 1, 1/2. 2 to the 0. Anything to the 0 power is
1.
Great job. My ordered pair is 0, 1.
2.
Let's plug in 2 to the first. You're right. It is a 2. So these 3 ordered pairs I just found, I want to graph. Negative 1, 1/2. 1 to the left and up 1/2. I'll do it in purple. 1 to the left and up 1/2. I don't even go to 1. It's halfway in between. 1/2. Halfway in between the box. 0 and 1. 0, 1. And then graph 1, 2. The curve shape that I've just made is called an exponential graph. It never touches that line. It gets really close, but it never, closer. It's never going to touch that. That line, by the way, is the line y equals 0. That's called my asymptote. What's the line that it gets really close to? And I can't, it's hard to do because it's in black, sorry. y equals 0. My asymptote is y equals 0. My graph gets really close, it never touches. Let's refresh our brains on domain and range. It's been a while. Domain is me going from left to right. So I've always used the ruler. Notice how my line's going to go forever to the left to negative infinity. So it's at negative infinity because it's all the negatives. Then it comes forward. And isn't it slowly just go up, 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 more to the right, more to the right, more to the right? So it's going to end up like negative. The purple line's going to be over here. Negative infinity, negative, 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 negative. And then, yeah, the line's still going to go that way. So that's going to eventually, I mean, it'll be here, but up, right? It'll hit right there. Or even up here, way up there. This is all positive infinity that it goes towards. And I write that as all real numbers. So let's talk about what it asks you to write for specifically on the final. I could say negative infinity to positive infinity, or all real numbers. My range. Range, if you'll recall, is when I go from low to high. So, start way down here. My graph, my purple line is not at my ruler. Nope, nope, nope. It hits, where does it start to appear? At 0. But it never touches 0. Because remember, it's never supposed to touch that red dotted line. So, my range is going to be y. So it's at 0 and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 is greater than 0. It's not or equal to 0 because it never touches 0. So I've got number 8 done. The key it's called a key feature. What's important about it? My domain. Where does my graph appear when I go from left to right? Range. From low to high. Where's my graph? Oh, starts right there. Yep. Asymptote. What's that line that it gets really close to but never touches? Which is also my K. But this equation, number 8 plus nothing. It didn't have a K. 0. It had nothing at the end of it. We're going to do number 9 together. I'm not giving you any graphing for homework. I really think it's important that you get it, so I want to do it with you. Tell me the transformation that happens with this H and K. 1 to the what and 2 to the what? One to the right and 2 up. Now, I already know that my asymptote, I'm moving my whole graph up 2, which means that my asymptote is going to be at 2. Because K is the same thing as my asymptote. Okay. First job. Graph 3 to the x. That's different than number 8. And then move the graph 1 to the right and 2 up. So first job, I don't know about 3 to the x. I haven't done that in a long time. 3 to the power of x. It's not the same as number 8. Okay. Let's pick still small, -1, 0, 1. Um, 3 to the negative first power. 3 to the 0, 3 to the first. Okay. 3 to the negative first power. 1/3. 3 to the 0. Anything. Yep. 3 to the first.
3.
Good. Okay, so those are the ordered pairs that I'm going to graph first. This is called my parent function. Remember that word parent function? Where are my other graphs originating from? 3 to the x is the parent function, and then I'm going to do a shift and a movement. So, okay. -1 up 1/3. I'll do it in, I should do my parent function in purple. -1 up 1/3. 1/3 is even like really close to, it's hard to distinguish between 1/2 and 1/3. 0, 1. That's the same as before. But now it's 1, 3 instead of 1, 2. So there's my parent function in pencil. Parent function. I want to move every single ordered pair 1 to the right and 2 up. So you're literally just doing a movement of, here's an ordered pair. 1 to the right, 2 up. 1, 2. Make a dot. 1 to the right, 2 up. This dot. 1 to the right, 2 up. It'll hit the same point. This dot. 1 to the right, 2 up. So it's going to shift. We're going to draw a second line right now. Start here. 1 to the right, 2 up. 1, 2. So I just did the first point. This point, 1 to the right, 2 up. It's going to overlap. Last dot, 1 to the right, 2 up. So it shifted a little to the right. Now it's never going to touch. It's never going to touch the line y equals 2. That's my asymptote. That's the line it never touches. I find out the asymptote because it's the k. It's that 2 at the end, that number at the end. Let's just do domain and range of my purple. Domain and range of purple. You guys, the domain is going to be all real numbers for all of these. Left to right, it's going to go forever negative infinity. Forever positive infinity. Domain, all real numbers. You would like type it out in words, all real numbers on the the Troy, we like to use something called interval notation, and that's where I do the negative. Maybe this pen is running out of ink. Negative I guess so. Negative infinity to positive infinity. But my range, low to high. Low. It's not at negative infinity. My purple line's not touching there. Nope, 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 no, 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 no. It gets really close to this 2, but it doesn't touch 2. So that's going to be y, because range is the y, is greater than 2. Another way to write it would be, I put parentheses 2, comma, infinity. That's the interval notation way. So that's graphing. For sure, graphing is on the final. All right, we'll go to the last page, which is growth and decay, where we use calculators. Remember how we were using calculators? You're not allowed to use this calculator that I have on the final, but there's a calculator embedded into the final. So you'll be able to use that. And it's important that when you're taking the final, you look at the calculator and say, how do I do an exponent? How do I... Okay. All right. Turn the page, please. Here is the formulas for growth and decay. One right, two up. Let me talk about it after I finish recording. Okay. Growth, exponential growth. That would mean something is growing at an alarming rate. Like, there's no way that we can count. Well, we could count, but it'd be like, we'd have to research tons of data. Like, every day in the whole world, the babies that are born. It's like the population just grows, but we could contact every hospital and say, how many today? But that's crazy. So, then decay. Then do we know decay would be, people dying maybe. Or a car value depreciating. Something, stock price is going down, decay. So, growth and decay. You only know what something is based on reading the math problem. A savings certificate of $1,000 pays 6% annual interest. What is the balance after 5 years? So I'm going to put $1,000 into the bank, and then I'm wanting to know what am I going to have in 5 years? Is my money growing or is my money decreasing? Growing. That's going to be my growth. Here we go. So, the formula, P, what I start with? P is $1,000. My rate has to be written as a decimal. 0.06. Yep. 6%. You move it 2 decimal places to the left to make it a decimal. 0.06. 0.06 time. How many years do I want? C. 5. So this means that in my calculator on GoFormative, I'm going to have this information. 1 plus 0.06 raised to the power of 5. The calculator on GoFormative is not as great as my calculators. I can't just put it in left to right. I have to do 1.06 to the 5th power first. So let me get a calculator that's not the one that we love, because bummer. Okay, just a normal calculator. 1.06 to the, now I have to find the exponent. My. Come on, Casey. Raised to the power of, where's the exponent? You see the, oh, here, duh. Raise this box right here. X to the box. 5. So this caret symbol is another way to write an exponent. That number, 1.338. If I wanted to round, which I always should round to make my life easier, I guess just 1.3. So, my math problem is 1.3 times 1,000. You have to do the exponent first. Order of operations. And then you multiply. So on your on your GoFormative calculator, 1,000 times 1.3. $1,300. So after 5 years, if I let my money just sit there and I never withdraw money out, I will earn $300 for doing nothing. So this is a benefit of having money in a savings of some sort, or doing a mutual fund, or investing in some sort of stock market. You just let the money sit there, you don't touch it, and the money grows for you. You don't even have to go to work. The money grows. But I have to wait 5 years. That's a long time for $300. Question.
So that's how much they get after 5 years?
Yeah, their original $1,000 back and $300 more.
But that's a waste.
What? Well, maybe you didn't need the money and you just wanted to save. You could do that. But yeah, $300. I mean, 5 years. You guys could go to work and make $300 in 1 month. So
1 week.
1 week, whatever. 1 day, whatever. All right. Number 11, you have to do for homework. I'm almost done recording. Let me just finish real quick. It's about a car depreciating. What does it mean when a car depreciates? Decay. That's this formula up here. You have to use the P, what I started with, my interest rate, my time, and there's a subtraction sign in the middle. Because I am losing money every year that goes by. Cars do not grow in value unless they're classic or collector items. So, it's a decay problem, and you'll do 11 for homework. Okay, let me stop the recording.